So in this video, we're going to be talking about exponents and scientific notation. So there are some rules of exponents that are very helpful. If you're multiplying, you're going to keep the base and you're going to add those exponents. So if we look at this example right here, the bases are all 6. You're going to keep that base. You're going to add those exponents. So just add those up. 7 plus 5 is 12, plus 3 is 15. It would be 6 to the 15th. And when it's such a large number like that, it's probably good to just leave it 6/15ths. If you try to put 6 to the 15th power into your calculator, usually that uses that little caret button. Um, if you try to do that, it's probably going to give you a very strange answer because that's such a big number. Now let's think about the next rule. The next rule is if you're dividing, you're going to keep the base. You're going to subtract the exponents. It's always top exponent minus bottom, top minus bottom. And so we have a combination that's happening in this problem. The top is a multiplication. So we are going to keep the 6. We're going to add those bases, 7 plus 3, or those powers, I'm sorry. 7 plus 3 is 10. Now it's a clear division. We're going to keep the 6. We're going to subtract the exponents. So it's always top minus bottom, in this case, 10 minus 5. So that would be 6 to the 5th. Again, keeping it 6 to the 5th is okay. Now, if it's something like to the second power or to the third power, you probably want to do that. But in this case, just leave it like that. And read what the instructions are in the problem. If they say to keep it in exponent form or keep the power, do it. If they say to, use a calculator, you're going to actually do that out. Okay. Now this one, it formatted a little funky. So I'm going to rewrite it over here. So that's x to the 7th times x to the 5th times x to the 3rd. And when I'm writing out like algebraic problems, I like to use that little multiplication dot more than I like an x, because is it an x or is it a multiplication? So, but even if the base is unknown, like this, a variable x, leave it in x. Keep the base, add the exponent. So just like we saw before, 7 plus 5 plus 3 is 15. Now here, the bases have to match. So the y's on top, the bases are alike. We're going to add the exponents. The x's are not. So you're going to leave that as you see it right there. So there wouldn't be anything more we can do, because the rule is only if the bases are alike do we combine the exponents. Again, this one formatted a little funky, so I'm going to rewrite x to the 7th times y to the 5th times y to the 3rd. So if you take a look at this problem, these y's have the bases are alike. These x's have no matching base, so we're going to leave that in x to the 7th. We're going to keep the base. We're going to add those exponents. 5 plus 3 is 8. So that would be your final answer. Now, technically, algebraically, you don't even need that dot between them or a multiplication symbol. When the x and y are next to each other, that is going to imply that you're multiplying them. Let's do this one. Now, what's interesting about this one is we have x's on the top and x's on the bottom. The only one that is different is our y. So that one's going to stay. We are going to use our rules of exponents on those ones. So we're going to keep the base of x. We're going to subtract the exponent. Top minus bottom, 7 minus 5 is 2. And then we're going to have a y cubed. So that's probably the most efficient way to write it. You can definitely put a dot between them. You can put a little multiplication x between them. Again, I don't like using the multiplication x if I'm using other x's, so I do tend to use that little dot. It seems to work pretty good. Another rule that you should know, If you have anything at all to the 0 power, it is always equal to 1. Now, 0 to the 0 power isn't defined as anything, so it would come up as an error if you were to enter that into a calculator. But any other number to the 0 power is always equal to 1. Here are some rules about scientific notation. If you have some number, A point B, weird notation the way it's written there, but where A is from 1 to 9 and N is an integer, um, so it can be any integer. So integers are the list that we see here. -3, -2, -1, 0, 1, 2, 3, going in both directions. Positive exponent means that the number is larger than 10, and negative exponents means that the number is smaller, a decimal value of some sort. So, like if we see a number 2.7 times 10 to the third, that technically is the number 2700. So, see how that positive exponent means that it's a larger number. And then if we see something like 5.2 times 10 to the negative third, that means it's a smaller number. We actually divide by 1,000 instead of multiplying. And we'll get into that more in a little bit. And that's that number. So positive exponents multiply by powers of 10. Negative exponents are going to divide by powers of 10. And that's why one is smaller than the other and one is large. So it says to convert from standard to scientific by moving the decimal point to the right of the first digit in the original number and counting the places you moved. Okay, and you also have to count the direction you moved. Okay, so here's your decimal point. We're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9 to put the decimal place so that our front number is between 0 and 9. So we're going to get 1.25. So I'm going to write that first part to remind us. And then we're going to count again. How many places did I move to get to that spot? 1, 2, 3, 4, 5, 6, 7, 8, 9. And I moved it to the left. When you started out with a large number and you had to move your decimal 9 to the left, we need a positive 9 in our answer. So if it's more than 10, you should get a positive value. Now let's do the same thing here. So this time we have to move to the right to get a number between 1 and 9. 1, 2, 3, 4, 5, 6, 7 gets us to be the number 3.16. That's 10 to the negative 7 because we've moved to the right. So if you have to move the decimal to the right, the negative 7 will move it back to the left. If you move your decimal place to the left, the positive 9 will move it back to the right to you. So if it starts out being a number bigger than 10, you want a positive exponent. If it's a number less than really less than 1, then you are going, so 0 point something, you will have a negative exponent. Now to go the opposite way, the negative number or negative exponent indicates that we are dividing by powers of 10. And the positive exponent indicates that we are multiplying by powers of 10. So it's a large number. So this means that you're going to move the number you see out front. We're going to move to the left 8 places. This one tells me to move to the right 9 places. Okay, excuse me. If I move to the left 8 places, so think this, we have to scooch under the 2 is one of the moves. So I put my 0 point, and that doesn't count as anything. And I just start counting 1, 2, 3, 4, 5, 6, 7, 8. So that would be 8 places. And we'll check it here in a second. So if we put our decimal place here, 1, 2, 3, 4, 5, 6, 7, 8. So you can see how from the original decimal point, we've gone to the left 8. So this one, our decimal place has to go to the right 9. So we have to use 3 jumps to get past the 635. Okay, so 2, 6, 3, 5. And then we need 6 more zeros. 1, 2, 3, 4, 5, 6. So that's our new decimal spot. And you can put every third one from there, your commas, to make it a little clearer, the place value. But you can see from this spot, excuse me, we've gone 1, 2, 3, 4, 5, 6, 7, 8, 9. And so it became much larger than when it started. Now, how about multiplying in scientific notation? Multiply in scientific notation means we multiply the values in the front first, and then we're going to deal with the powers of 10. Okay, so let's first deal with these two numbers. Now, so if we multiply 1.324 times 2.111, we get a number with more decimal places than we started with. So I'm going to write out the whole thing and then we'll deal with that in a minute. Now, we also have these powers of 10, 10 to the 7th, and 10 to the negative 5th. 10 to the 7th times 10 to the negative 5th. Keep the base, add the exponents. 7 plus negative 5 is the same as 7 minus 5, or 2. Now, it's a good idea because these were to the thousandths, so 3 places out. Most likely just read the instructions, but rounding to that same place is very common. So let's round this 4, sorry about that, and let's move that and make that jump up to a 5. So I think most likely that would be how they would want your answer, but always follow those instructions, however they say how many places out they want. It says when a product or quotient that doesn't result in proper scientific notation, you need to put it in that form. Now, what's proper scientific notation? This number out front has to be a number between 1 and 9. And so if you look, that 2 is telling us what we want. So we want the decimal place to land. So it says 2.5833. Okay. So how many places did we move that? Well, that's a number bigger than 10. That's a positive power thing. That's 200. And so that is really 10 to the 18th, and we have moved it 2 places. So that 2 is positive again, because we're indicating that our original number was more than 10. Now, the rule is if the bases are alike and you're multiplying, we add the exponents. Negative 18 plus 2. When the signs are different, you subtract, get 16, keep the bigger sign, negative 16. So this is times 10 to the negative 16. So those two numbers are equivalent, but this one is in proper form. This number should always be between 1 and 9. To divide scientific notation numbers, we're going to kind of split it into 2 pieces. We're going to divide these two. We're going to combine those two using our rules of exponents. So if we do 6.958 divided by 1.23, we get 5.6569. One, we'll put a 1. Okay. Now, 10 to the 12th and 10 to the 15th, if the bases are alike and we're dividing, we subtract the exponents, so it's always top minus bottom, so we get 10 to the 7th. Now, always check, am I in the proper scientific notation? You are. That front number is 5 point something. It has to be between 1 and 9. It is perfect, perfect. I think our longest decimal place is the thousandth, 3 places. So if they decided to have you round to 3 places, it would be 5.657. Since this 6 has a 9 after it, bump it up 1. So that is that one. Now let's do an application problem. A solution contains 2.15 times 10 to the negative 4 milligrams of drug per milliliter. Now I'm going to write that down. 2.15 times 10 to the negative fourth milligrams of drug per milliliter. I'm going to put 1 milliliter in the bottom. Okay. The client requires a 4.25 times 10 to the seventh milligrams. How many milliliters should be administered? So we're gonna set it using a proportion. So 4.25 times 10 to the seventh is milligrams. So it goes in the top of our fraction, and our unknown, our x, would be milliliters. It's going to go in the bottom. Now that's a proportion that needs solved. So just cross multiply. And then the numbers that you cross multiply, the ones you didn't use, you're going to end up dividing. And it always works like that. So it really is going to be 2.15 times 10 to the negative fourth x equals 4.25 times 10 to the seventh, because 1 times anything is just that thing. So as you can see, what did we divide by? We ended up dividing by the 2.15 times 10 to the negative 4. So our x, which is our milliliters, is going to be that division. So we're going to do it just like we did the other problem. We're going to divide 4.25 times, or I'm sorry, we're going to divide 4.25 and 2.15, and we're going to get 1.9767. We'll talk about that in a minute. And then we're going to get times 10 to the seventh minus the negative 4 is going to be 7 plus 4, which is 10 to the 11th. And so when we do that, here's the thing. The originals were 2 decimal places, hundredths. So let's take that to the nearest hundredth, okay? So the 7 is our hundredths spot. Look behind it, it's more than 5 or more, so it's going to be 1.98 times 10 to the 11th. Now, the instructions didn't say how many milliliters, or how to round it. But if you look at the digits in the original, that sometimes is a good clue if you're unsure how to round. So there's a little bit about scientific notation. Thank you so much for watching. I hope that helps. You have a great day.